going to talk about inverse of a function. Inverse functions are any pair of functions that undo each other. An inverse function can be attained by interchanging the placement of x and y. So let's go ahead and start out with the function 3x minus 2, f of x equals 3x minus 2. To find the inverse function, the first thing we want to do is we're going to solve our original function for x. Okay, that's the first step. So I'm actually going to write this as y equals 3x minus 2. So I'm going to first set that up, and I want to solve that function for x. Okay, so I look at it, I add 2 to both sides. Okay, that cancels. I'm left with 3x equals y plus 2. Okay, I then divide both sides by 3. I end up with 1x equals y over 3 plus 2 over 3. Notice we divided both parts by 3. Now, I guess you could leave it as x equals y plus 2 all over 3. But I write it in this format just because of our next step here is to switch or interchange x and y. Okay? So step number 1, first thing, and then number 2. So we have x equals y over 3 plus 2 over 3. We want to interchange x and y. So these two things just trade spots. So we are going to then write that as y equals x over 3 plus 2 over 3. And notice we're almost into like slope-intercept form. In fact, if we think of that as 1 over 3x, we could write that in slope-intercept form as y equals 1/3 x plus 2/3. Okay? And since this is y and this is y, rather than having them both equal y, let's call this one, this was actually f of x, let's call this one g of x equals 1/3 x plus 2/3. Okay, so we've now found that the inverse function of f of x equals 3x minus 2 is g of x equals 1/3 x plus 2/3. Okay, all right. So here's our original, here's our inverse. Let's go ahead and graph both of those. And the way we could graph them, we could use just slope-intercept form, right? We could say, well, this is y equals mx plus b. I know this is my y-intercept, and this is my slope. Okay, I could do that. I'm actually going to go ahead and fill out a table and then kind of use my slope to help me out. So like if I have -2 here, if I found f of -2, that would be 3 times -2 minus 2, or -6 minus 2, which is -8. Okay, and then if I did say like f of -1, that's 3 times -1 minus 2 equals, well, that's -3 minus 2, which is -5. Well, no, I mean, we should know the pattern here. This should be increasing by 3 every time, right? How do we know that? Well, that's our slope. Right? A constant rate of change, we go up by 3. Okay, so this would be -2, 1, and 4. Okay, so I could plot those points, just like I could have said my y-intercept was -2, and then I rise 3, run 1. Okay, that would have been fine as well. But since I have a table, let's go ahead and use that table. Okay, so I've got -8, -2. So -8 actually is right here. -8 is right there. So, and then -2, so kind of down there. I know that's off our -1, -5, or yeah, -1, -5. No, I'm sorry. -2, -8 would be down here. And then -1, -5, 3, 4, 5. And then 0 for y-intercept, and then 1, 1, and then 2, 4. All right. So we have this line. like this. Okay, we call that the graph F. And we just label it F because this is f of x over here. Okay, now to graph G, well, there's a couple ways to do it. First, you could do the same process we did here where we, or right here where we calculated, we fill in the table. But dealing with fractions is not as appealing. And one of the statements I made at the beginning, the inverse function can be attained by interchanging the placement of x and y. That's huge. That means what was x in my original function actually becomes y in my inverse. What was the input becomes the output. So my outputs, I could say -2, -1, 0, 1, 2. And my inputs are actually my other outputs, my original outputs. Those, they just trade spots, right? And now I have a whole set of points I can plot. So if I'm graphing G, -8, -2, well, -8, -2 is right there. And -5, -1, 1, 2, 3, 4, and 5, -1 is there. -2, 0, that's right there. Okay, and let's see, 1, 1 is right there, and 4, 2 is right there. There's the graph of G. Now I leave it short just for a second because I want to point something out here. If I didn't have a table and I just had a graph, note you have these same points right here, like -2, -8. That point is right here. And you could still find its corresponding inverse point by switching x and y. So the inverse would be -8, -2. Well, that point is right here. We just switched our x and y. And this one right here, which is at -1, -5, right? Well, its inverse would be -5, -1, which is right there. And notice it's actually there in the table. So if you're not given a table, you you already have the points here. So my question would be, what point are we missing? Notice we're missing one of these points. Okay, this point, look, we could go up 1 and over 3, right? If we're using our slope, 1/3. Okay, this coordinate right here is 3. Well, did we have a 3, 7? No, we didn't, but that would have been our next point, right? Okay, that would have, that would have been not 7 there, but 7 there and 3 there. Okay, so that point right there, 7, 3, which is here, is actually 3, 7 on this one, which should be right there. That means I missed it just a bit. I was off on my graph. Didn't use a straight edge, but 3, 7. So if you're given a table, you can just interchange the x and y's. The other thing to note is if I were to put in this line right here, this line is the line where you have the ordered pair 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That's called the line y equals x. This point is a reflection over that line to that point. This point reflects over that line to that point. They're reflections. Inverses are reflections of each other. The graph of an inverse function is a reflection of the original function over the line y equals x. Okay? And one other piece, what's the domain of my function here in red? Well, the domain means where does it exist on the x-axis? Well, every input for x could potentially have an output, so it's all real numbers. Well, the domain of your original function actually becomes the range of your inverse. How come that is? Well, range represents y, domain represents x, and x and y switch. Now that may not seem as amazing once we go through the range, because the range is, where does it exist for y? Well, it's also all real numbers. But that range, actually, of the original, the y becomes the x, so the range becomes the domain. And that'll come up a little later. But hopefully from here you've seen how you can go from an original function to an inverse function by using algebra. How you could use a table to find the inverse. If you know the table of an original, how you can switch it and make it the table of an inverse. And then graphically, how you could actually graph the inverse from the original, either by using points or reflecting. It's easier to just switch the points, just so you know. Okay, let's try some problems here. Writing a formula for the input of a function, solving the equation for x, in other words. That's what we're saying here. So solve for y equals f of x. Solve for y equals f of x for x. I think this should read solve y equals f of x for x. Okay, so let's kind of edit that there. So in other words, what this means right here, it means where you see f of x, write y. Okay, so there. Now we have y, right, equals 3x minus 2. Solve that for x. Well, what's my first step? I add 2 to both sides. Okay, so over here I get y plus 2 equals 3x. How do I get rid of that 3? Well, I divide both sides by 3. So I get x equals y plus 2 over 3. I have now solved for x. Now, it doesn't say what format we have to have it in. It does not say find the inverse, right? Whereas here we were finding the inverse, so after we solved for x, we had to switch the values. Here, it just said solve for x, so we solved for x. All right? Now, find the input when the output's 4. Well, what's input mean? Well, input stands for x. Output stands for y. So find x when y is 4. Okay, well, let's go ahead and do that. Let's go ahead and put 4 in for y. So we have 4 plus 2. Right? Oops, that's not how that should look. That's ridiculous. Okay? 4 plus 2 all over 3 equals x. That's 6 over 3 equals x. So 1x is 2. There we got it. There and there. Very good. Okay, well, let's try this next one here. It says, oops, once again, we are solving for x. We're going to make f of x be y, just replacing f of x with y. First step, divide by 16. So we end up with y over 16 equals x squared. All right, well, the next step is take the square root. Now remember, anytime you impose a square root, you have to put plus or minus in front of it. You get y over 16 equals x now. All right, take the square root of both sides. Okay, well, the problem with this is you have a fraction and a radical, and we can't do that. So let's go ahead and rewrite that without a fraction in the radical. So we break it apart. And now the problem is you have a radical in the denominator. So let's rewrite without the radical in the denominator. Just so happens that root 16 is 4. So we'll write it like that. So there is my inverse. Or not my inverse, but my solving for x. Now, let's go ahead and use that and find x when y is 4. I'm going to write that as plus minus the root of, well, y is 4, over 4 equals x, which means plus minus 2 over 4 equals x, which actually is plus minus 1/2 if we reduce it. So x equals positive and negative 1/2. All right. Let's go ahead and try another set here. Find the inverse of that function. So hopefully you're pausing and trying these on your own. But if I find the inverse of that function, f of x equals negative 1/4 x plus 3. Then graph the function and its inverse. Well, let's start with that here. All right. We're going to go ahead and method 1 is just the method we've been talking about. So I'll walk you through method 1 and then I'll tell you about method 2 here. Method 1, first, we always solve for x. Okay, so once again, I'm going to make this a y equals. So we have, I solve for x, I have y equals negative 1/4 x plus 3. First step, subtract that 3 over, right? So subtract 3, subtract 3. I have y minus 3 equals negative 1/4 x. Okay, that's canceled. All right. Next step, multiply both sides by negative 4. They're divided, like the reciprocal of negative 1/4 is negative 4. So if I multiply by negative 4, negative 4 times negative 1/4, negative times negative is positive, and 4/4 is 1, so that just gives me x. And here I get negative 4y and positive 12. So x equals negative 4y plus 12. Second step, switch x and y. Okay, so I take x equals, let's do that right below it, x equals negative 4y plus 12. So bring that over. Okay, and we switch x and y. So, oh, I don't need that. Those two just trade spots. I get y equals negative 4x plus 12. I now have the inverse. Now it says graph the function and its inverse. So let's go ahead and graph this function first. Y equals negative 1/4 x plus 3. And I'm going to just use slope-intercept form. So y-intercept and slope. Okay, so we go 1, 2, 3. We go down 1 over 1, 2, 3, and 4. Up 1, 1, 2, 3, and 4. Very good. We have our function of f here. Go ahead and draw our line. All right, there is f. All right. Now g. If I want to use my y-intercept of 12, that's not going to fit on the graph here. And I didn't, by the way, I didn't rename this as g, so let's do that. Let's call that g of x. So that way it's not confused with f of x, and we don't have a y equals and a y equals. Now g of x. Now, if I want to plot that, it's a little tougher, but remember what we talked about. If you know points on your graph already, so we know these coordinates. We know that this coordinate right here is 1, 2, 3, 4, 4. So negative 4, 4. Okay, so I could take that one, and I could take this one, which is at 0, negative, or 0, 3. And I could take this one right here, 4, 2. And I can just swap those, right? I can trade the x's and y's. So negative 4, 4 becomes 4, negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. There we go. All right. And 0, 3 becomes 3, 0. You just switch the x and y's. And 4, 2 becomes 2, 4. Okay. And then you can draw your points, or draw your line through your points, and you have the graph of G. Remember, to check your work, you could draw in that line, y equals x, that one that goes 1, 1, 2, 2, 3, 3. It kind of has that diagonal, and you should see a reflection there. And we do this a little off right here just because I straight hand. I used just freehand there. All right, that's all there is to it. Okay, well, method 2, by the way, if you want to do method 2, I'm not going to work through it, but method 2 is just to do this in reverse order. You could start by switching x and y. That would be the first step, and then not solve for x now, you'd solve for y. Okay? So maybe I will show it real quick. Y equals negative 1/4 x plus 3, right? So we could start by switching those. That would be the first. So we'd have x equals negative 1/4 y plus 3. And then we'd solve for y. So we'd subtract 3, so we get x minus 3 equals negative 1/4. Multiply by negative 4, so we get y is equal to negative 4 times x minus 3 right? Which is exactly what we had up here. It's just negative 4x plus 12 equals y, which we could rewrite then as g of x equals negative 4x plus 12. The same idea. You just do it in the reverse order. All right. Let's go ahead and talk about functions. Just a quick reminder. A function is any graph that will pass a vertical line test. It's any graph that for which every x value has its own y value, has a unique y value. An x value doesn't have two different y values associated with it. Okay, so what we talk about is vertical line test. If I were to take and draw a vertical line, or use a vertical line and move it along this graph at any point, does it hit my graph in more than one spot? And the answer is no. So this passes. This is a function. Okay, this one, well, right here and right here. I mean, look, there hits it in two spots. Here it hits it in two spots. Not a function. Okay, here. Yeah, okay, looks good. Function. Passes the vertical line test. Here, okay. My class today, some students got hung up with it right here. They're like, hold on, right there, doesn't it hit? Well, this is actually a point of inflection, so the answer is no, it doesn't hit in more one spot at the origin, so this is a function. Okay. So that's called using the vertical line test, and we've done that before, okay? However, you could also use a horizontal line test. If I were to take, let me kind of maybe use orange here. Okay, I could go this way. And if I use a horizontal line test on a graph, notice now my graph hits here and here on the horizontal line test. What the horizontal line test tells me is if you test it and it hits in more than one spot, it's actually the horizontal line test tests for the inverse function. Okay? Since your original function does not pass the horizontal line test, its inverse, oops, spell that right, is not a function. So really, by doing the horizontal line test, you're testing, you're doing a horizontal line test, but you're figuring out if the inverse is a function or not by using that. And so like over here, my original is f of x equals x cubed. The inverse is f of x equals the cubed root of x, or g of x equals cubed root. So I go to the horizontal line test. Notice it passes, right? And once again, some of you may argue right here, but that's a point of inflection. It actually passes the horizontal line test. So here, since the original function passes the horizontal line test, its inverse is a function. Okay, you're testing for the inverse. So the horizontal line test can be used to determine if an inverse will be a function. Just another tool for you. Okay. Well, let's go ahead and talk about one more piece here. Okay. Finding the inverses of a quadratic. Find the inverse of f of x equals x squared, and then you have this thing. So most students are really pretty comfortable at this point in math. If I say, hey, you have f of x equals x squared, I want you to graph that. Most students are like, hey, no problem. It's just when you add junk like this, not junk, okay, but when you add stuff like that, it really kind of makes things seem a lot more complicated in math. So what I'm going to do, I'm going to just ignore this for a minute. Okay, that's called a restriction. Like you're being restricted. You're being told you can only do a specific thing, or you're being limited to a certain area. And we can restrict graphs, just like maybe your parents would restrict you from your phone or from friends or something. You can restrict graphs, and that's what this thing that I just crossed out did. We'll come back to that, so don't scribble it out hard on your paper. I can erase real easy, okay? So f of x equals x squared. Hopefully you know by now, if I wanted to graph x squared, I could say, well, that's 0, 0, 1, 1, 2, 4. If you cannot do that, then you need to create a table of values. X, f of x. Okay, and you start plugging in values. Hopefully you know how to find the vertex, okay, because that's your starting point, 0, okay, or maybe you just started at 0, 0, and then 0 squared is 0, okay, and then 1 and 1 squared is 1, and then 2 and 2 squared is 4. That's all I've done now, okay. So if you remember from graphing quadratics, what you do is you graph one side of a parabola, and then you'd have the axis of symmetry, and then you'd reflect these points, and you graph the other side, right? Well, notice I only gave you part of a graph, and I didn't make a mistake. Somebody was like, well, maybe you made a mistake. I didn't make a mistake there, okay? Why is that? Because of this amazing thing called a restriction. This is saying graph this when x is greater than 0. That means when you're looking at this graph, you're only allowed to graph over on this side when where x values are bigger than 0. Over here, these x values are less than 0. You can't graph over there. So that would mean you can only graph on this side of the graph. Okay? Because x is greater than 0 over there. So that means I only get to see half of the graph. That's what the restriction tells me. Okay? Well, let's look at its inverse. All right? The inverse of f of x equals x squared. So what we're going to have to do for the inverse, first thing is we're going to have to write it as y equals x squared. We're going to go ahead and solve for x. So we're going to take the square root. So we get plus minus square root of y. Remember, when you take square root, you got to put plus minus. That equals x. And switch x and y at the end. So now we have plus minus the root of x equals y. And let's go ahead and rewrite it as, put the y over here and the x over here, okay? And then we'll call it g of x. Now here's the deal. We had a restriction. Our restriction on our original function was a restriction on the domain, or a restriction on x. We have a restriction here. However, the restriction is no longer on x. Our restriction, just like x and y's change and inverses, well, your domain and range change. Your restriction's on y. Okay? No longer is it x is greater than or equals 0, it's y is greater than or equals 0. When the domain of a function is restricted, the same restriction is imposed on the range of the inverse. And that's what we've done. Remember, range stands for y, domain stands for x. Okay? And so when I'm looking at graphing this, when I graph the square root function, well, the plus minus square root function starts at 0. The root of 1 is 1. The root of 4 is 2. That is the square root function. Oh man, I didn't mean to get rid of all that highlighting. It was so amazing over there. Got to go back to it. I'm sure there's some kind of an undo feature I could do there, but there we go. Okay. So there's my square root function, and that, by the way, is the root, the positive root of x. The negative root of x would be down here. However, note that the negative root of x, remember we have plus minus root x here, the negative root of x is actually, the negative root of x is down in this area. And really, we got a restriction. Y is greater than or equal to 0, which means we have to be up on this side of the y-axis. The values that are bigger than 0. Okay, that means we're graphing over here in that same quadrant now. Okay, which means this negative root x, we don't want that because it's against our rules. It's against our restriction. Okay, we can't use the negative root x. We can only use the positive root of x. And you don't have to put the positive in that. All right, so there we've done it. We found the inverse. We've graphed the inverse. And we've made sure our restrictions match up. Hopefully that makes sense there. Let's try one more problem. Find the inverse of f of x equals 2 times the root of x plus 4. Is the inverse a function? Well, I'm going to answer this question right away. I know what this picture looks like. It's a square root function, so it's going to start at a point and it's going to zip off in one direction like that. What I know is, if I want to know if the inverse is a function, I could try the horizontal line test on it. Does it pass horizontal? The answer is yes. Therefore, yes, it is a function. It passes the horizontal line test. The original function passes the horizontal line test, therefore it is a function. All right, I think that's supposed to be a u there. Okay. Now let's actually calculate what the inverse is. We did all that before we even figured out the inverse. Okay, so we have y equals 2 times root of x plus 4. So first thing, let's solve for x. Going to divide by 2, so we get y over 2 equals root of x plus 4. Next step, I'm going to go ahead and square both sides. Get rid of that root. Okay, so this is going to give me x plus 4 is equal to y squared, right? We bring that into here and we bring it into there, over 2 squared. Well, y squared over 2 squared, I'll just call that y squared over 4, and that equals x plus 4. Next step, we're going to go ahead and subtract 4 from both sides. Okay, so that's gone. I now have y squared over 4 minus 4 equals x. And let's rewrite that in this format. We'll have x equals y squared over 4 minus 4. And now we've got to switch our x's and y's, right? So it becomes y equals x squared over 4 plus or minus 4. Now this is a quadratic. In a quadratic, we don't generally write in that format. I mean, it kind of looks weird because we're dividing by 4 here. So this is 1x squared. So let's actually call this y equals 1/4 x squared, right? 1 over 4x squared minus 4. And then we'll replace the y with g of x. There we got it. There is your inverse. And by the way, that inverse is, well, it's a quadratic. So the picture looks like this, which passes the vertical line test, so therefore it is a function. We just already knew that because our original one passed the horizontal line test. Okay, that's all I got for you. Good lucky.